going to do this warm-up right here. And in the warm-up, we're just making a table of values by substituting numbers into 2x plus minus 1. So you'll do 2 times negative 1 minus 1 and put your answer. 2 times 0 minus 1. You will use your calculator to do that, okay? Take a couple minutes to do that and see if you get the same thing as your neighbors. So in the warm-up, we're making a table of values just by substituting these numbers in for x. And so each number will go in for x. 2 times negative 1 minus 1, you should get negative 3. 2 times 0 minus 1. 2 times 1 minus 1. And 2 times 2 minus 1. And this over here is a picture of a function machine, which means you put your x into the function, and then you get the y out of the function machine. So I put the negative 1 in, I get out the negative 3. But today we're going to learn about function notation, which is instead of using y, you use f of x. Just another way to write it, but you need to be able to understand what it's asking you when you use function notation. All right, so here's an example of function notation down here. Instead of y equals 2x minus 1, it says f of x equals 2x minus 1. F of x is short for f is a function of x. So we substitute a value of x to get the value of y. So over here, we had already done 2x minus 1 with these numbers. So I could just put in like a couple more numbers like 3 and 4. Okay? So if I put in 3, I do 2 times 3 is 6 minus 1, I get 5. And if I put in 4, 2 times 4 is 8, minus 1 is 7. All right, so you see how it works exactly like y. You're putting x numbers in, you're getting f of x numbers out. Raise your hand if you've ever seen f of x before. Good. So some of you have seen it before. If you haven't seen it before, just remember that it acts like y. But the way you write some things can be interesting. We'll see. So it says functions are not always f of x. They could be g of x or h of x. Those are the most common ones. And then sometimes they'll use another letter. Here it says evaluate the functions for f of 5. So this is what we're doing for each one. So f of 5 means put 5 for the x. 2 times 5 plus 1. When it says f of 5, you don't do anything with that. That just means this is what I'm finding, a function of 5. Everything that you do is on the other side. So I get 10 plus 1, which is 11. Notice I didn't do anything with f of 5. I'll do one more and then I'll give you a minute to do the others. F of 5, a function of 5, is 2 times 5 minus 3, 10 minus 3, or 7. Okay? So we're just like understanding what does it mean when I ask you to find f of 5 right now. And it just means put 5 for the x. So go ahead and do that for the others, and then compare with your neighbor. And then for this one, negative 15 plus 1, so I'm getting negative 14. So are we agreeing? Yeah. All right, so when I ask you to do f of 5, all I'm saying is put 5 for the x. So when you're ready, you can turn the page. I'm just leaving that for another 30 seconds.
Wait, what are we putting on the table above?
I'll show you in a sec because some people are still looking at this. I just substituted 3 and 4 into the equation 2x minus 1. I think your partner probably has it.
But the rest.
Oh, I didn't finish the table. Yeah, because we had already done that table, so
Okay.
if you look above, it's the same equation. Okay, turn the page. Okay, so now it says evaluate when x equals 4, and notice that these are some more complicated equations. So for example, the first one, remember f of x and g of x mean the same thing, they're just different names. So I can do g of 4, and then you just substitute the 4 for the x. All right, so go ahead and do that. You're going to use your calculator. All right, so for each one, we're substituting 4 for the x. This one I get 2. H of 4, 2 root 4 minus 1. I get 3. Did you guys get 3? Oh, Q. I haven't seen Q. Q of 4. 4 plus 5 squared. Should get 81. Oh, you guys should tell me what you're not seeing what I'm seeing. And then W. W of 4. Negative 3 times 4 plus 1, negative 11. Are we agreeing? Who has a question? Does anybody need to see how to do something on the calculator? Okay. All right, so this is the part that might seem a little bit more new, evaluating functions based on the graph. Remember that f of x is replacing y? So this is still our x-axis, but this is now our f of x axis, okay? Because f of x is just another way of saying y. When we have a 0 where the x is, that means I need to find the place on the graph where the x is 0. So looking at your x-axis, find 0, and then go to the graph. So looking at the first one, what's the y value when x is 0? Right here. Is it 2? Oh, it's counting by 2. Yeah, that box is 2. I can see it now. If you have bad eyesight like me, it might look like 1, but it is 2. All right, and that's because we were looking at this point right here. Okay, f of negative 2. Go on the x-axis to where x is negative 2. And what's the y value? 0. So I was looking at that one right there. And that was 0. I'm going to go down here now. Same graph, but this time they're telling us f of x is 3. So that means that the y is 3. I need a brand new color. I wonder if that's going to work. I'm going to try it. Okay, so this means that the y is 3. So I need to go up to where y is 3, which is like between the boxes. And I need to go over and find out what point that is. I think, honestly, I need to like wait for this thing to stop moving. Yeah, freeze it. You guys with stronger eyes, it looks like the x value is 1. Is that what you're getting? Okay. I'll unfreeze in just a sec. So the x value is 1. All right, so I did that one in orange right here. And I'm going to have to zoom out a little bit. There you go. So when the y value is 3, the x value is 1. So now I need you to work on these other graphs, and I'll come around to see who needs help. All right, guys, I'm hearing some really good discussions. I'm going to start going over it right now. So the first one says f of 0, so that means the x is 0. On the x-axis, you find 0, and then you go up and you get 3. F of 2, the x is 2, and so you go up, and I think you get 5. Are you guys reading the graphs the same as me? Oh, thank you very much. All right, so the first one, when x is 0, the y is 3. When the x is 2, the y is 5. Guys, if I say the wrong number, let me know because I really don't see these graphs very well. My eyes are just a little bit old. The last one here, f of x equals 3, this is the y number. So I go to where? Up? Yeah. I have to be able to see this too. So I go to the same point as before, here where the y is 3, now the x is 0. So really this one and this one was the same problem. Just two different ways of writing it. All right, next one, f of 1. So I want to know when the x is 1, what's the y? I get 2. F of 0, when the x is 0, what's the y? I get 4. Questions there? You doing okay? Okay. F of x equals 0. This one is y. So when the y is 0, what is the x? That's over here.
2.
Yeah, good job.
Wait, the one you just did, that's asking when the x is 0.
No, when the y is 0. So this point here is 2 comma 0. The orange point is 2, 0. So when the y is 0, the x is 2. For some reason, points on the axes seem more difficult than other points. I don't know why. All right, last one. When the x is 1, over here, what is the y? I'm getting 2. When the x is 0, the y is 1. Okay, this one here, when y is 0, that's down here. When y is 0, x is negative 1, because this point here is negative 1 comma 0. All right, so this is just reading the graph. Looking at the graph, given an x value, find the y value, or given a y value, find the x value. I think we only have one page left, right? It's going to be interesting, though, because it's about transformations and it's about f of x notation. Mm-hmm. Will you wait 5 minutes? Because I want you to see this. You've been next, okay. All right, on the next page. Here's a graph, and we don't have a name for this function. It's not x cubed. It's not absolute value x. It's really not anything with a name. It's actually called a piecewise function that has different pieces to it. But we don't need to piecewise, like piece and then wise, yeah. All right, so we can still transform it. This one is named g of x. That's the name of the function. And so you can see I'm trying to find this, g of x minus 2 plus 3. The transformations work the same as the ones we did on the whiteboards. So x minus 2, that's the one that goes backwards from what you think. So it's going to go which direction? It's in parentheses.
Right.
Okay, so very good. It was a left-right transformation. And then because those happen backwards from what you think, it's right 2. So we're going to shift right 2. The plus 3 shifts us which way? Up 3, good. So the way you do that is that you take each point, see how there's 4 points here? Take each point, shift it right 2 and up 3, and then you'll connect them to make the same pattern. Okay, so I did the first one, I shifted this point. You're going to do the other points too, shift them right 2 and up 3, and then connect them to make the same picture. All right. Now that points out, I shifted left. It says to shift right 2, so I have to go right 2, and then I have to go up 1, 2, 3, right here. So I just put an X on that point, and I made a new point. Then you're going to do the same thing with the next point. Right 2, and then up 1, 2, 3. Right 2, up 1, 2, 3. And then right 2 and up 1, 2, 3. All right, now those points, you want to connect them in the same pattern. So it's down, up, down. So we just picked up that whole piece and went right 2 and up 3. This is brand new, so make sure you're getting that on your paper. We did 1 point at a time. Right 2, up 3. Right 2, up 3. Right 2, up 3, and right 2, up 3. All right. We're gonna do the same order of operations down here that you would normally do. Normally you would multiply before you add, and that's what we're gonna do here. So doing a vertical stretch of 3 is tricky. What you do first is you take your y value and you multiply it by 3. So my y value is 2. 2 times 3 is 6. Then I add 2 to it and I get 8. Okay? So this one here had a y value of 2. I multiplied it by 3. I added 2. Now it's going to have a y value of 8. It goes straight up to where y is 8. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. It goes all the way up here. Okay? This point is going to do the same thing because the y value is 2, so it's going to go up to 8. I'm going to do one more with you, and then you guys are going to do the last 2. What's the y value of this point? 0. 0 times 3 is still 0, and then I add 2, and I get 2. Okay? So take the y value of the point, multiply it by 3, and then add 2. All right, let's see how you did. Down here, your y value is -2. 3 times -2 plus 2. I get -6 plus 2, which is -4.
So do you move it down?
So it's going to move to where y is -4, which is down, yeah. This one has a y value of 0. 3 times 0 plus 2 is 0 plus 2, which is 2. So it moves to 2. And then what you're going to do is you're going to connect the points in the same pattern. So first across, and then down, and then like a little parabola, like that.